Hello everyone, welcome to today's webinar. Today we will go over Unit 4 and it is the third part of this unit. I initially announced that this unit will be covered over 3 webinars, but I decided to extend that to another 4th webinar that will take place next Wednesday. Today we will go over roots and we will learn how to multiply, divide, and rationalize radicals. This is myself. My name is Miriam. I'm your math instructor here at Penn. I am certified to teach high school math in the state of Pennsylvania, and also I have earned my master's degree this year. In this webinar, we're going to go over some challenging problems from the third section of the unit Exponents and Roots, and we're going to go over, as I said, multiplying, dividing, and simplifying radicals. Participants today, attendees, are able to practice some self-check questions throughout the webinar. Those questions are not graded or anything. They are just given here in this webinar to give you a chance to self-assess yourself. So whenever you see that self-check question, please feel free to participate in that question. Your questions, of course, are welcome, and they need to be relevant to what we speak about in this webinar. At the end, if we have spare minutes, at the end, I'm happy to answer your general questions about the course or the program. Also, all registrants for this webinar will receive a recording of the webinar in a follow-up email. Multiplying and dividing radicals will be the main focus of this webinar. So let's look at some problems. The first slide will be the basics, the simplest kind of problems that you may see when you are asked to multiply radicals. So when we added and subtracted radicals in the previous webinars, we said that the radical part of our numbers should be identical. This is not the rule for multiplying or dividing. We can actually multiply or divide any radicals, no matter if they have the same or different radical parts. So in this case, we're going to apply those rules. Rule number 1 says that if you have a radical times another radical, what you want to do is just multiply whatever under the 2 radicals and combine them under one radical sign. So the square root of a times the square root of b equals to a and b multiplied, and then take the square root of everything here. And the same thing, there is another rule that we gonna use a lot in our work with multiplying radicals. The square root of a times the square root of a, so you are actually multiplying the square root of a number times itself. It should give you only the number under that radical with no radical signs. It will become clearer when we do some examples together. So let's do the first example. The square root of 3 times the square root of 5. What should we do? Now, typically, we look under each radical sign and see if any number under that sign has a perfect square factor. Remember the table that we went through, the chart of perfect square factors 4, 9, 16, and so on. Our job is to find if any number under the radicals have any perfect square factors. In this case, our numbers are so small, 3 and 5, and we know that 3 does not have any perfect square factors, and the same thing for 5. In this case, let's apply the rule directly and multiply 3 times 5 and put the product under one square root sign. So the answer will be the square root of 15. Now, typically, when we arrive at an answer, we ask ourselves, is this the simplest form of the answer? Is 15 has any kind of perfect square factors? In this case, the answer is no. So this would be your final answer, the square root of 15. Now let's do number 2. So the first step that we said we're gonna do is inspect each number here. I see 8, and I know 8 is 4 times 2. 4 is a perfect square. Then I need to break down the 8 first, simplify the square root of 8, and then multiply that to the square root of 3. I'm doing that because if I kept everything till the end, and then at the end I have to simplify anyway, the simplifying process will be so big for me to do, because when I multiply, I have big numbers, and then I have to break down those huge numbers to another smaller numbers, and I need to see if they have perfect square factors or no. It is always easier to simplify from the beginning. What I'm going to do is I'm going to represent 8 as 4 times 2. I'm still multiplying times the square root of 3. Now, the square root of 4, I know is 2. So this expression is actually can be written as 2 the square root of 2. So the square root of 4 is 2, which is outside here, and then 2, the other 2, remains under the square root sign. And then I need to multiply times the square root of 3, because this is our problem. And then since nothing can be simplified under the square root sign, I'm going to go ahead and multiply. Now I see a 2 outside, and we know in algebra we do not write the 1. So actually there is a 1 there before the square root of 3. What I'm going to do is multiply 2 times 1 is 2, and then multiply the radical parts. As we said in the rule, 2 times 3 would be 6. So that is your final answer. That is your final answer, to the square root of 6. Let's do number 3. And at any time, if you have a question on one of those problems, you're not sure how did we get the answer, or you're not clear on one of the steps that we have done in any of those questions, you can write your questions in the questions box. I'll be able to see your question and also who asked the question. Let's do number 3. The square root of 10 times the square root of 5. Now I know that 10 does not have perfect square factors, 5 does not have perfect square factors. I'm going to go ahead and multiply them. So it will become the square root of 50. Now 50 have a perfect square factor, 25. So I'm going to break down the 50 because I always want to put my answer in my simplest form, the simplest form I can get. So that is 25 times 2, which is 50. The square root of 25 is 5, and then the square root of 2, and that's your final answer. Next, number 4, the square root of 13 times the square root of 2. 13 does not have any perfect square factors. The same thing for 2. Then go ahead and multiply. 13 times 2 will give you 26. If you inspect 26, you will not find any factor of that to be a perfect square. Then that would be your final answer. So remember, you don't have to simplify if you can't. You only simplify if it's possible to simplify. Last question. The square root of 101 times the square root of 101. That's basically the square root of 101 times itself. So this rule now applies. And the answer would be actually whatever under the square root sign, 101. And if you want to know why we end up with that answer, remember in the previous, I would imagine the first webinar, we spoke about, or the second webinar, if I'm not mistaken, we said that the square root is actually an exponent of a half. So 101 to the half exponent, or 1 over 2 exponent, times 101 to the half power. And we learned that when we multiply the same base, we add the powers. So 101 to the first is the same as saying 101. That's why when you multiply a square root times the square root itself, it will get you whatever under the square root sign. Any questions here? Anything that was not clear or you had questions? Okay, let's move to the next bunch of questions. This is going to get a little bit harder. When I looked at the study unit and the practice questions on division and multiplication, I didn't find them so challenging, but when I looked at the exam has more challenging questions. So I thought to bring in some more challenging questions than the one that you may see in the study unit, so you are prepared for the exam. Okay, what if, and we covered that in question 3 in the previous slide, if I'm not mistaken, it was number 3. If you have a number times a square root, and then you have to multiply that times a number in square root, we actually multiply the numbers there and then multiply the radicals using the rule. So what I'm going to do is, since 7 and 6 does not have any perfect square factors, I'm just going to multiply. 5 times 3 is 15, and then 6 times 7 will give you 42. If you look at 42, you will not find any perfect square factor for it, so that would be your final answer, 15 times the square root of 42. Question number 2, negative 2, the square root of 8x. Now we see variables in our questions. Times 10, or the square root of 10 times y. Okay, well, I mean, the rules will not change. If we have variables, if we have negative numbers in front, the rules stays the same. Now, before I'm going to go ahead and multiply, I notice an 8 here. 8 has a perfect square factor because 4 times 2 gives you 8. I need to break down this before I go ahead and multiply and end up with huge numbers. So what I'm going to do is I'm going to do that, rewrite this as negative 2, the square root of 4 times 2x times, well, 10 doesn't have any perfect square factors, so it's going to stay the same, 10y. All I have done here, just I rewrote everything so I get to see the perfect square factor for the 8. Now, let's apply the square root only for the 4, because it's the only one that I can calculate the square root for. So, negative 2 times 2, because the square root of 4 is 2, so I'm going to end up multiplying 2 times the negative 2. So negative 2 times 2 is negative 4, and everything else will stay under the square root sign. I'm still multiplying times 10, the square root of 10y. I'm not done yet. I need to perform the multiplication. So I can go ahead and multiply. Negative 4 times 1 is negative 4. And then 2x times 10y will give you 20xy under the square root sign. Now I see 20, and I know that 4 times 5 is 20, and 4 is a perfect square factor. Let's rewrite that to see what we mean by that. So 4 times 5, that's the 20 here, times xy. So I can take the square root of 4, which is 2. 2 times negative 4 is negative 8, and then everything else will stay under the square root sign. And your final answer would be negative 8 times the square root of 5xy. Any questions? Anything that was not clear in that problem? Okay, let's move on to 3. So we have 7 times the square root of 10y cubed times 3, the square root of 5. The only difference here, or the only step up that we have in that question, is the variable now has an exponent. If you remember from last webinar, we said any variable under the square root sign that has an odd power, we need to break down that power to an even and an odd power, and then take the square root of the even power by dividing it over 2. Let's do that together. It's hard when I just talk about it. So equals 2. So I'm trying to simplify everything before I multiply. So I have 7. 10 does not have a perfect square factor. It's going to stay as 10. The y cubed can be written as y squared times y. If you want to multiply these two, you will get back the y cubed because we add exponents. 2 and 1 is 3. Times 3, the square root of 5. I cannot simplify that any further. So let's take the square root of y squared, which is going to be y, and y has to go outside. So 7y, and then 10, because that's here, not a perfect square factor or number, and y also will stay inside. I'm still multiplying times 3 times the square root of 5. Okay, since everything in simplest form, I can go ahead and multiply. 7 times 3 is 21y, because I have a y here with a 7. And then I'm going to multiply 10 times 5 is 50, and I have a y. And then I'm going to ask myself, is 50 is a perfect square number or has a perfect square factor? And the answer is yes. So let's rewrite that as 25 times 2, which is 50, and then we still have the y. Apply the square root to 25. The square root of 25 is 5. 5 times 21 will give you 105. I still have the y outside, so it has to stay outside. And then everything else will stay under the square root sign. And that would be your final answer. Any question in that problem? Anything that was not clear? Okay. Let's proceed to the last example on that slide. Negative 2 times the square root of 3 times negative 7, the square root of 3. What catches my eye is that radical part and this radical part are identical. And the rule says when you multiply radical times itself, your answer will be whatever underneath the sign. So we're going to multiply negative 2 times negative 7. Negative times a negative is a positive, so it's going to be 14 times 3 equals to 42. And in this case, your answer is a whole number. Even though you were multiplying radicals, it's okay. If you're applying the correct rules the correct way and your answer happened to be a whole number, then that is your answer. Let's proceed to a self-check. So these are the questions I were referring to at the beginning of the webinar. These are not graded. I'm not going to evaluate you or your understanding based on those questions. Those are given for you to assess yourself and see if you're okay with multiplying radicals, or maybe you want to ask a question, or maybe you want to revisit the unit and see why or how come we have that specific answer for this question. What I'm going to do also is I'm going to keep this slide for about 30 seconds, and then I'm going to switch my screen to another screen where it has the same question, and then you have the chance to input your answers. So you can have your time, you can copy down the question and apply the rules that we have been talking about since the beginning of the webinar. I'm going to keep quiet for a while to give you a chance to think about that. Okay, I'm going to change my screen now to give you the same question and a chance to share your answers. And here you go. Okay, I'm glad to share my answer for this question. When you get the recording, you can pause the video if you didn't have a chance to enter your answers and do the question one more time and compare your answer with the answer of this question. C is the correct answer. Anyone want to know why C, or did not come up with the same answer and they do not know why they end up with the incorrect answer? If you do want me to go over it, let me know. You can type yes or yes, I want to see the question. Okay, then let's proceed to the next half of the presentation, dividing and rationalizing radicals. Okay, so apparently we're gonna divide. We're gonna divide radicals, and we have to go by certain rules. And the rules are simple. If you see on the top right corner, this is the rule. If you're dividing the square root of a divided by the square root of b, you can actually divide a over b and take the square root of everything, or the square root of the quotient. Or you can distribute. You can do the square root of a divided by, that's the fraction sign, the square root of b, so that b does not equal to 0. You're going to see that a lot across the study unit because you know anything over 0 is undefined. So they have to put this condition there. So let's apply the rules then. We're going to perform the same steps that we did with multiplication, except that we're going to divide at the end. One, we need to make sure that every number under the square root sign does not have a perfect square factor before we proceed to the actual division. Now, 15 does not have a perfect square factor. 5 does not have a perfect square factor. Then I can go ahead and divide. So Ken just gonna write it out for you for the first time here, and then just divide mentally afterwards. So it's like dividing 15 over 5 and taking the square root of the quotient. So that would be the square root of 3, because 15 over 5 is 3. So the answer is the square root of 3. Since 3 is the simplest form here, does not have any perfect square factors, then this would be our final answer. What about 2? The square root of 8 divided by the square root of 3. 8 has a perfect square factor. By now, we're gonna be so familiar with numbers. When they pop up in our question, we would know directly that they have or have not any perfect square factors. By now, we know 8 has a 4, and 4 is a perfect square factor. What I'm gonna do is I'm gonna break down the 8. 4 times 2, I'm still dividing over 3, equals 2. The square root of 4 is 2, so 2 has to go outside, and then the other 2 will stay inside or under the sign, divided by the square root of 3. Now I can go ahead and apply the division rule. So I'm going to have on the top 2, the square root of 2 divided by the square root of 3. Nothing to be canceled out, nothing to be simplified further. This would be your final answer. Now, this final answer is not in simplest form, because one of the rules says that if you have a fractional radical, meaning that you have a fraction with radicals on them or on it, you cannot have a radical in the denominator. You cannot have a radical expression in the denominator. That would make this not in simplest form. At that time, we need to use rationalization to make this answer in simplest form. In rationalizing any fractional radical, we do as follows. We multiply top and bottom times the radical part that appears in the denominator, times the square root of 3 and times the square root of 3. This process in blue, we call it rationalizing the radicals or rationalizing the denominator. Now, if we multiply this times that, notice that we're going to multiply the square root of 3 times itself. So that will get rid of the radical sign in the denominator. So let's do the multiplication then. So we're multiplying 2 the square root of 2 times the square root of 3 divided by 3, right? And then equals to, just simplify, just multiply 2 times 3 will give you the 2 square root of 6 divided by 3. And this is your simplest form of the answer. This is your final answer. This is a correct answer here. 2, the square root of 2 over the square root of 3. It is a correct answer, but it's not in simplest form. So be careful whenever you are dividing. Check. If you have a radical in the denominator, you have to rationalize the denominator using this method. Any question on this? Okay, let's do another example. The square root of 100 divided by the square root of 75. 100 clicks to my mind because 100 is actually itself is a perfect square, meaning that when I take the square root of 100, it will give me a whole number. It's 10. So let's rewrite the question. So I'm actually dividing 10 divided by the square root of 75. If I look further on the 75, I will realize that when I multiply 25 times 3, it will give me 75. Then 75 has a perfect square factor, 25, and times 3 here. So let's simplify. Let's rewrite the problem. 10 divided by 5, the square root of 3. Okay, everything is simple. We can now divide. Let's divide. So 10 divided by 5, the square root of 3. The only thing I see that we are able to do is to simplify the 10 with the 5. So if I divide over a 5 on the top, that would be a 2. Divide over a 5 on the bottom, it's going to be a 1, like we do with normal fractions. So now it's going to be 2, the square root of 3. Now I need to look at this answer. This answer is not in simplest form because I have a radical in the denominator. What should I do? I'm going to rationalize the denominator by multiplying top and bottom times the square root of 3 over the square root of 3. So multiply, that would be 2, the square root of 3, and then the square root of 3 times itself will be 3. And that would be your final answer. Any questions? Okay, let's move forward to more harder questions. Okay, 48, the square root of 48 divided by the square root of 7. 7, I know, nothing there for perfect square factors, but 48, I'm thinking about 16 and 3. 16 and 3. So equals to, let's rewrite the problem. So it's the square root of 16 times 3 divided by the square root of 7. Simplify further. The square root of 16 is 4, so that will go outside the square root of 3 divided by the square root of 7. Nothing to simplify further, then write them in the fraction form. 4 square root of 3 divided by 7, or the square root of 7. Now the square root of 7 in our denominator, we do not like that. We cannot keep that like this. So rationalize the denominator, multiply times the square root of 7 over the square root of 7. In this case, we're going to multiply this times that, so it's going to be 4, the square root of 7 times 3 is 21. And then over 7. That's it. So 4 and 7, nothing to cancel out. 21 does not have a perfect square factor. Then that would be your final answer. Any questions so far? Anything that you did read maybe about it in the study unit, but it doesn't match what I say here in the webinar? Okay, let's move on and do number 2. The square root of 50x divided by the square root of 8y. Now we have still to deal with variables. So let's think about the 50. 50 has one perfect square factor. It's 25. 25 times 2 will give you the 50. So let's rewrite. So it's 25 times 2, and I still have the x. Extend the sign. Divided by 4 times 2 will give you the 8, and I still have a y here. Apply the square roots to perfect square numbers. So we have 5, the square root of 2x for the first one here, and then divide over 2 the square root of 2y. Let's rewrite that in the fraction form since we cannot simplify anything further. So equals to 5 square root of 2x divided by 2 the square root of 2y. It's a correct answer, but we need to rationalize the denominator. Multiply times the square root of 2y. I'm not going to multiply both top and bottom times 2 the square root of 2y. I'm just going to multiply times the radical part that shows in my denominator divided by 2 the square root of 2y. Now multiply. 5 times 1 is a 5. And then the square root of 2x times the square root of 2y will give you the square root of 4xy divided by, well, I have this times that will give me whatever inside or under the radical expression, which is 2y times 2 will give you 4y. Now I see a 4 under the square root sign. I need to simplify that. So the square root of 4 is 2. 2 times 5 is 10. The square root of xy divided by 4y. 10 and 4 are even numbers. Divide over 2. It will give you a 5 here. Divide over 2 will give you a 2. Let's rewrite the final and simplest form of the answer. 5 square root of xy divided by 2y. That's it. One more example with variables, and this time one of the variables has an odd power. What should we do? Well, I'm going to follow the same steps. Think about the 63. 63 is a multiple of 9, and 9 is a perfect square factor, so I'm not going to proceed to divide unless I simplify my problem first. So I can rewrite this as the square root of 9 times 7, and I still have the r to the third power, divided by 28 is a multiple of 4. So it's 4 times 7, and I still have my r there. Apply the square roots for perfect squares. Or you know what? Let's break down the r as well, since we are breaking down everything to get ready to apply the square roots to perfect squares. So that's actually r squared times r, which is going to give you back the r to the third. Now let's apply the square roots. Now the square root of 9 is a 3. It has to go outside. 7 will stay inside. The r squared would be an r, and then the other r will stay inside or under the sign, divided by 4. The square root of 4 is 2. That will go outside here. And 7r will stay under the sign. Let's rewrite everything in terms of fractions. 3r square root of 7r divided by 2 the square root of 7r. Well, I see the radicals the same. Any number over itself is what? 2 over 2 is 1. Negative 1 over negative 1 is 1. The square root of 7r divided by the square root of 7r is 1. That's canceled out. Our answer is 3r over 2. And in this case, we did not need to rationalize the denominator. We do not have anything in the denominator to rationalize. So that is your final answer. Questions before we go to the self-check. Anything that was not clear on the rules or the steps, or how do we think of a problem or start the first step in a problem? Okay, that's a good sign. So let's go to the question. The square root of 3 divided by the square root of 32xy. So I'm going to keep myself quiet until you think about the problem. Remember, the same rules, the same steps that we followed. Okay, I'm gonna put the question up for you to share your answers, please. Here you go. Okay, let me share my answer. And as I said, you can pause the video and practice. So the final answer, the right answer is C. C is the right answer. Let me know if you need me to go over this question. You can type in anything to indicate so. Okay. That is the end of my math part of the webinar. Today we went over how to multiply, divide, and rationalize radicals. We were supposed to cover the how to solve radical equations, but when I went through the unit, I thought that it's going to be too much for you to digest everything about multiplication, division, rationalizing, and solving radical equations. So I saved that for another session, which is going to be on the 6th, which is Wednesday, if otherwise announced. So please register for that session. I have sent an email to everyone who has registered to this webinar. So they have the link for the 4th webinar. So if you did not do so yet, please register for the last webinar session. How would you prepare for an exam? Of course, you want to read your unit. You're not going to depend on this webinar only for your exam. You're not going to depend on, your memories of high school years if you had done that topic back in high school. You want to read the study unit. You want to follow some examples that's given within the unit. You want to do some questions, practice questions, or sometimes they call them discover more questions. Either way, they give you the answer key for those questions, and this is how you're going to use the study unit to assess yourself and see if you're ready for the exam or not yet. Other resources, outside resources that you may use is khanacademy.org or YouTube. You can just go in and type in the search bar rationalizing radicals, for example. There is a bunch of good videos out there. It's not too complicated. The questions that they give, some of them are not too advanced, so it is on the right level of this unit if you want to do extra work, of course. How would you seek help? You can call the school from 9 to 6 Eastern Time. If the instructor is not available, you will leave a message or speak to a teacher assistant, and they will deliver your message to the instructor, and she or he will call you back. You can schedule an appointment using this link. You can choose the course that you want to meet with the instructor for. You can prepare your question ahead of time, and we will call you back on the time that you mentioned at the time of your registration for the appointment. If you have a quick question, so brief question that you do not want to call and stay online or email and wait for a response, you can text message. If you have an instructional question about your studies, you can text learn with this number, and somebody will get back to you. We try to respond as soon as possible. Also, you can email your instructor if you have a detailed question and you would like a detailed answer. Some students, they have this kind of platform and others have this kind of platform. Choose the one that your account is on and follow the steps on how to find where to email your instructor an email. You want to keep the subject relevant to your content, so your email gets forwarded to the right department. If you have a math question, for example, you want to title your email, for example, an algebra question or a math question, and so on. And thank you for your attendance today. Thanks for your attention and participation in those questions. At the end of this webinar, there is a survey, a quick survey of 2 questions only. This survey helps me assess myself and see what's missing maybe in my webinars that I can add, or maybe the webinar was not clear enough, or maybe the webinar was too good. I would like to hear your opinion, even if you did not attend today. You are able to click on the link that you will receive in the follow-up email and take those 2 questions and tell us your opinion. The link that you see here in this slide is the link for the 4th session for this unit. So if you did not get the email about the one last webinar that I decided to add, you can also type in this link and register for the very last webinar on Unit 4. We have some time left over. If you have some questions for me, general questions specific to algebra or specific to this unit, let me know. You can type in your questions in the questions box. I'm just going to wait for about 30 seconds or so you think about the question and type it in. Okay, I guess everyone is okay for the moment. If you think of any questions, you know now how to communicate with the staff here with your questions. I wish all the best for you in the exam and good luck.